Hello, this is the first video in the fifth matrix series for OCR Pure Core Further Mathematics. It introduces using matrices to solve two simultaneous linear equations. We can solve simultaneous equations using matrices. You can't divide by a matrix, but you may remember from previous videos that pre-multiplying by its inverse has the same effect. So here we have a matrix M acting on a coordinate point xy to give an image x1, y1. You may remember that the identity matrix 1, 0, 0, 1 for the 2 by 2 matrices is formed when we multiply a matrix M by its inverse. M to the minus 1 is the notation we use for that. Thus, if you follow the working on this slide, you can see that pre-multiplying by m to the minus 1 allows us to identify the original coordinates x and y. Here is an example to make that clearer. We start with the two equations, 3x plus 2y equals 5 and 5x minus 4y equals 3, and we can rewrite this as a single matrix equation, where m will be 3, 2, 5 minus 4, acting on xy to give the resultant 5, 3. If we look for the inverse of this matrix, we would see that it was 1 over minus 12 minus 10, which is the AD minus BC, and then minus 4, minus 2, minus 5, and 3. We've covered finding inverses on previous videos. We tidy this up a little bit. We would see that we can reduce the number of negatives we are dealing with. If we then pre-multiply by that inverse, we will end up with, I'm keeping the fraction outside because it is easier to work that out at the end, 20 plus 6 and 25 minus 9, giving a result that the x would be 13 over 11 and the y 8 over 11. To do this example, let us just remind ourselves about how we work out the inverse matrix. We need to work out that determinant, AD minus BC. We swap around the A and the D, and we change the sign of the other two elements. Thus we can see that for C and D, 3 times 4 minus 5 times 2 would be 1 over 22, so C and D have made a mistake in calculating the determinant. In A, they have not swapped around the A and D correctly, therefore B is the correct solution. So when we're dealing just with two variables, we know that linear equations can be represented in a plane by two straight lines. So when we solve them, there are three possibilities. Let's think about what they might be. That the lines cross at one point. We may find that the lines are parallel. Or we may find that the lines are actually coincidental or the same line. So we either have a solution, no solution, or an infinite number of solutions. In this case, if there is the solution where there are two lines that meet at one unique point, then the determinant of the associated matrix is non-zero. In the other two cases, the determinant is 0. In this example, we're asked to find the two values of k for which the equations x plus ky equals 5 and kx plus 4y equals minus 10 do not have a unique solution. So in other words, we're either looking at parallel lines or a coincident line. And they're asking how many solutions are there in each case. Let's write this as a matrix equation. So 1k, k4 times x and y would equal 5 minus 10. If there is no unique solution, then the determinant of that matrix must be 0. In this case, the determinant is 1 times 4 minus k squared. This leads us to the conclusion that k is either 2 or minus 2. When k is 2, we would have that x plus 2y equals 5 and 2x plus 4y equals minus 10. We can see that the second equation there is in effect a multiple of the first in terms of the x or 2x, 2y, 4y, but that the answers 5 and minus 10 are not multiples of each other. Therefore, we are talking about parallel lines, so there is no solution. K is minus 2, we would have x minus 2y equals 5, and minus 2x plus 4y equals minus 10. These are multiples of each other, so it is the same line. Therefore, the lines are coincident and there are infinite solutions, number of solutions. In the next video, we will consider solving 3 simultaneous equations using matrices to find a unique solution.